And I'm also super excited to have been able to recruit, an all-star team of researchers in this space. And I see Paul's already here. So Paul Goldsmith-Pinkham from Yale is going to be the first presenter. And he's going to talk about the pricing of climate risk in municipal debt markets. Paul, very glad to have you here. Thanks for giving us your time.
Yeah, of course. Thanks so much for inviting me to do this. I was going to say I'm so glad that I'm first, but of course I had to follow you. I was going to say there's an all-star team after me, but unfortunately there was a leadoff hitter that was also very good. We're going to use baseball metaphors. Thanks a lot. This is definitely. I'm really excited to do this. To some extent, I think out of all of the participants today, I'm probably the most novice on this. My co-author team is kind of an all-star team of people who've worked on this. I assume, Johannes, you can see my slides, I assume.
Yep.
Great. So yeah, so this is, I think I echo Johannes's excitement, maybe more as a peripheral person, but about the importance of this, both enthusiasm in terms of it as a topic, and then obviously I think everyone kind of understands the sort of the relevance from just a purely, if you want to feel like your work is important kind of setting, this seems super important. So I'm going to touch base. I'm basically going to go over very briefly work that I'm doing with Matt Gustafson at Penn State, Ryan Lewis at Boulder, Colorado, and Mike Short, who's at Wharton. And conceptually, this is a paper that really fits pretty well into the overview that Johannes was giving. I think the motivation is perhaps unnecessary in this audience, but let me just set the stage because there'll be some other folks who are going to study different types of climate change will be thinking about this. And we have a pretty nice figure to think on this is that, really part of the reason there's been this growth, there's a number of reasons, but as things have gotten worse, people have become more interested, right? It's, when people start knocking on the door, you say, oh, I should probably have an answer for this, or at least be thinking about it. And part of the reason this has shown up is that the scientific consensus since the start of the millennium has basically gotten worse and worse. So this on what I'm projecting here on the left-hand side, this is something from our paper where this is thinking about from a bunch of different scientific studies, kind of what's the sea level rise that we're going to have at a global level by 2100. Now, 2100 is a long time from now. There are reasons why this has been the focus of sort of picking what the number of feet of sea level rise is going to be. But effectively starting in 2007, there's been a range in terms of what people expected, but the average consensus and kind of the distribution of this has continued to rise over time. Now, this is a global statement about a lot of things. It has to do, with rising temperatures, has to do with a vast variety of features of these models, but basically interest has grown because things are getting worse. And so, as people are expecting things to get worse, we really started to want to ask the question of like, what are the expected economic costs of sea level rise? Now, why is it useful to know the costs? For one thing, kind of the reason to know the costs is that then if we implement measures to kind of do remediation to address these issues, is we can understand, well, the benefit of doing that is by basically, if we fix this problem, well, the opportunity, we're not going to experience this subsequent downside. And what we want to do, and kind of what we're going to do in this paper, is try and exploit the fact that financial prices are forward-looking, and perhaps will give us a sense of what the underlying cost is. So that's kind of the motivation. I think, Johannes already gave a little bit of this. I wanted to give my 2 cents on kind of where we sit in this relative to other papers, and kind of give a sense of why we think some of the innovation of what we're doing is relevant. There's kind of a lot of existing papers already. You'll actually look, I think this is relevant to Johannes's statement previously, that in the existing paper, there's kind of climate and then there's a number of things. So real estate being a big one, that's one that we focus on in part because we're thinking about municipal debt that is heavily financed by local property taxes. There's a number of papers in that space. Oh, and I spelled my colleague's name wrong. Stefano Gigli, it should be Giglio. And then there's like climate and financial markets. So there's a number of papers related either to ours or in other settings, thinking about how financial markets are pricing this, thinking about kind of the risk and the hedging that can be done in the cross section that Johannes was talking about. And then there's also this macro literature that's really thinking about kind of the aggregate time series and kind of the costs of climate change in the aggregate. And the one reason I want to mention this is that there's a number of pieces here, and a lot of it has to do with hedging in the cross-section and thinking about looking at differences in the cross-section. And that's super interesting and important. I think Johannes said all these things at the beginning about, there's some places are going to do well, some places are going to do poorly. A lot of our estimates are going to try and understand the differences in this. But a kind of really important thing is we really kind of just want to know what the level effects are in a number of these places. And so kind of what we're going to be doing is we're going to be thinking about what's the effect of sea level rise exposure. We're going to be thinking about this in kind of by using bond credit spreads. And we're going to be thinking about this in a panel setting where we're going to be looking at relative differences and we're going to, very standard kind of diff and diff, but we want to translate this into like real economic estimates. And the reason for that is that you actually want hard numbers. And so I think there's this interesting point that I want to highlight before I just kind of diving into talking about only our paper, that a lot of the papers that I've seen or I've discussed or thought about with other people is this real tension between understanding the cross-sectional differences in what we see in terms of the impacts of climate change when we do stuff empirically, and trying to understand kind of the time series impact or like the level effect that we're not doing relative across one another. And hopefully that's clear for the folks in the audience that I think there's kind of a crucial element to which, similar into in macro, we don't want to just kind of know like one place is doing better than the other, but it actually turns out everyone is doing poorly. So it's very important to kind of understand the level difference as well as the relative differences across these places. So in our paper, as I mentioned, we're going to be looking at sea level rise exposure, specifically focusing on muni bond prices. And the way that we're going to do that is it's really going to have two pieces. There's going to be the first part that if you're an empirical person, you do applied micro, it's going to feel relatively straightforward, especially if you've seen some of this work. We're going to estimate the effect of sea level rise on municipal credit spreads. So, think of this as essentially we're trying to understand how much does sea level rise affect the desirability of holding certain types of bonds. And we're going to be focusing on the secondary market. What that's going to use is it's going to use kind of similar to a lot of the work in this real estate agenda is local variation based on the geography of school districts. So we're going to be looking at school district issuers. We're going to be comparing bonds from issuers who are in the same county, traded at the same time, but are going to be in different school districts. So we're going to have variation in the amount of sea level rise that they're exposed to. And what we're going to be able to exploit is basically the fact that we have differences across places. We can do this experiment in different types of places and with bonds of different lengths of maturity to kind of understand the nature of this risk. The kind of second thing that's a little more novel and what I was alluding to when I was talking about kind of the level is we're going to basically be taking a very simple model of credit risk. So this is about as simple as it gets. And frankly, this is still even the part that is not my area of expertise, but really trying to just take a simple model of credit risk and calibrate that, knowing what we see to kind of talk about the economic measures that we get. So we're just going to take like a Merton model, thinking about this being like an underlying bond, that's sort of like what you do in the corporate finance literature. And what's very nice about this is that then we can talk about, well, what's the implied underlying change in the fundamental value of the bond, given the bond yield changes. So the idea being that if we calibrate this model correctly, and we do counterfactuals thinking about here's the delta in terms of a bond yield change. Well, what does that imply about either the underlying volatility of the cash flow payments or the actual fundamental value of what's happening there? And the reason that's really useful is, say, I'm going to tell you a number of what our effect is, but if I don't give you a sense of what that implies about the underlying fundamentals, that's really only useful for a very narrow segment who either want to understand there's any effect or wants to understand something very specific to the bond market. But instead, this is going to actually have real implications for thinking about the loss to the actual underlying economy that's there. All right, so just to give you a preview in case, over the next 30 minutes, you start to slowly check out, let me just give you a sense of what the ideas are. The first is, as you might expect, we are finding that sea level rise is associated with higher muni bond spreads, kind of rising over time, basically very much in line with when the scientific consensus is saying, hey, you need to start paying attention to this. But what I want to emphasize is that, and this is actually to quote Johannes on this, is that since this is a lot of PhD students in the audience, it's actually useful to say, there's a very natural desire to kind of want to have a big effect. And then even if your effect is small, to sell it as being big. And it's like, this is actually small in the sense that it's like 6 bips, right? Like a 6 bips change in a yield spread, that doesn't feel huge. Now in the muni market, it is big. It's like a relatively large effect. This is on the magnitude of what you get from a bankruptcy filing by a municipality. But the point is like, these are not enormous, like huge impacts on the yield. Like you wouldn't necessarily even see it just by looking at the raw levels. But the thing is that what we're going to get to eventually is that this really, since munis are so safe, this is going to imply a huge effect, relatively speaking, on the underlying present value of cash flows. This is like an actually non-trivial effect on the underlying economic productivity of that. If you think about the model that just thinks about there being some, basically, if you think about the fundamental value of the asset that's underlying it, it's going to actually imply big changes in that because it's such a safe asset. So a really safe asset, when the yields move even by a small amount, that really has big implications about what's going on for the present value because it was so safe beforehand. So I guess the sort of the key things that we're going to do empirically, we're going to just kind of try and show a little bit of light on the underlying mechanism as well, where we're kind of the key takeaways I want you to have is that it's really going to be driven by the East Coast and the Gulf Coast. So for those who are not, for those in the audience who are not US based, there actually are huge differences in what the coastlines look like in terms of storm risk, in terms of storms more generally. Basically, the Gulf and the East Coast in the United States is typically heavily inundated by hurricane season, whereas the West Coast doesn't have that has that in a much lesser extent. The local tax environments are also very different. I'm not going to have the results today about this, but the California tax environment, thanks to Prop 13, creates a very different relationship between the local taxation and the municipal bond system. And then we're going to show that it actually shows that both in long and short run maturities, which suggests that storm surges, it's not just that you stand there and eventually the sea level rises, but it's also that due to climate change, some areas are substantially more exposed to storm surges, which is basically what happened to New York City during Superstorm Sandy, which was that water levels were up, but then the storm basically causes water to come up and surge temporarily and cause a lot of damage, even if there's not a permanent rise in the sea level. And finally, this is concentrated in states where people are worried about climate change. Now, that's a weird thing in a traditional financial market. Like you'd say, well, what does it matter where you are because this is a financial market? Muni bonds are heavily concentrated in ownership in the same state that issues them because of the tax benefits of it. Basically, if you own something from your own state, you aren't taxed on it. And so there's actually the extent to which your own locality affects the financial market matters in this context. Okay, I guess I don't have to stop for any questions, but I will pause there just to let you digest that, and then I'll keep going. So briefly, in the literature, I kind of mentioned some of this. I think what we're trying to do is we're kind of trying to fit into a literature that says there's a big one, as Johannes mentioned, that studies real estate markets for very good reasons. I think it's like super interesting. There's great data. It's both the lamppost is there and it's shining very brightly because there's very good data. It's also very important for the purpose of climate change. One of the things that we're going to be doing is we're really going to be kind of building on top of that because of the municipal markets we're going to be studying are heavily affected by real estate markets. They're from the taxation of these markets. They're paid by the taxation of these markets. There's also, some other papers that are thinking about firms and other types of settings, bond settings, where they're worried about climate risk. What's pretty novel for us is this application of this model. Now there are real caveats to this that I'll briefly mention at the end. Like this is not a great model for nailing the yields. We're not super well calibrated, but it's very useful in terms of thinking about changes in yields and changes in underlying fundamental value. And so it's really useful as a sanity check. I think we argue that this is useful to do in other settings where you're trying to think about, look, this is a bond instrument. This is an instrument where it's sort of fixed income, and we have these negative shocks that are happening, and we see changes in some price market. I want to understand what that implies for the underlying value of the asset. Not just on the pricing side, but I want to know kind of in terms of present discounted cash flows, what does that imply? Because that will have implications about how much I'm willing to pay to ameliorate these climate changes. And so mapping to some kind of model like that is really valuable. I'm not going to talk about it too much today, but it's actually useful for the purposes of this being a PhD class to kind of highlight, let me keep an eye on time, to highlight this fact that there's another nice paper by Marcus Painter in the JFE. We actually didn't know this paper when we started working on it. And so he's studying municipal bond markets as well in a different context. He is focusing on a different measure, not SLR, where he's using economic costs. We kind of really only find stuff in 2013, 2014 afterwards looking at SLR, and his is focusing on a different time period. Our results are also saying that there's an effect, but it's sort of much smaller and kind of we think it's more consistent with what the model implies. But it's useful to know this, that there's a lot of papers in this topic. There can be other papers in this topic, and I think what we're finding in this is that what we're having to do is kind of be a little bit more careful, since we weren't the first ones writing on munis and climate risk, that we had to really think about, okay, how do we frame our paper in this setting, since we don't get the benefit of being the first actors. And so something worth thinking about for those of you who are PhD students in the audience, it's very hard to be the first in something if it's something that is like, it's so salient to everyone else. And so really kind of shaping exactly how you want to do it is valuable. And I think that has pushed the paper to be better as a result. Okay, in the last 15 minutes, let me just sort of go through what we actually do. I think I've given you kind of a pretty good high level sense of it. What we're using bond yield data from Mergent. So this is really just a monthly panel of bond prices from school district bonds. So these are bonds issued by school districts from 2001 to 2017. Basically, there's a purpose that's indicated by Mergent. It's going to give us a good chunk of all municipal issues. This is actually a big chunk of the municipal market. And what we're going to do is we're looking at the secondary market. So we want to be able to see things that have enough trades. So we're going to be doing a pretty stringent sort of trading sample. So what we're going to be doing is focusing on a balance panel where we see enough observations. And then what we're going to be looking at is credit spreads relative to some tax exempt yield curve. So basically, this is just sort of fitting into this literature, but the idea is what we want to see is like, what's the premium above some baseline curve, some baseline yield. Then what we're going to do is we're going to tie this data from bond issuers to actually where there exists. So this doesn't actually, you have to do the work yourself to do this. They don't tell you this in Mergent, but you figure out all the school districts based on their names and the states that they're in. And we basically map the bond issuers to what school districts they are and figure out the geographic boundaries around them. And then what we do is we map all the houses that are in those school districts, and we figure out how much are those houses exposed to a certain amount of sea level rise. So there's a couple steps there. I'm going to show you some pictures, but the idea is relatively simple. You have bonds. Those are from issuers. Issuers are some shape geographically. We know all the houses that are in that shape. Then we got to figure out how many of them are exposed to, or to be inundated if sea level rises rose by a certain amount. Well, how do we do that last step? Well, that is actually all publicly available and kind of cool. Actually, and as an aside, the Zillow data is also quote unquote publicly available in the sense that you can apply and Zillow will let you get access to this. So if you're a PhD student interested in this topic, this is gettable. But how do you do the sea level rise thing? Well, NOAA provides this website. You can do this and you can actually get the underlying data instead. But here is a thing that you can go do, and you can scare yourself into this. This is New Haven. This is where I live. I live near East Rock Park over here. And you can be like, well, what happens if global sea level rises by, so this is right now. What if it goes up by 3 feet? So here's 3 feet. So not much happens in East Rock where I live. So there's a river that goes up to here, but you know, sorry. So basically at 3 and 6 feet, there's not much change in New Haven, Connecticut. So you can see there's a little bit. What happens in East Haven though, is that this whole area on the bottom of the screen effectively goes underwater. So all these estuaries from the river start to get much higher. And if you don't have a lot of like topographical rise, if basically you don't go above sea level very much, you're going to be underwater. Now, why does that matter? Well, now let's think about a much more famous place than New Haven, Connecticut. Here's Miami. Here's what Miami looks like right now. Here's Miami at 3 feet. And here's Miami at 6 feet. And so this is why everyone basically says like Florida is going to be gone if sea levels rise by what are expected. Because if you look at Miami Beach, for example, it's completely underwater by this point. So I think of this is like pretty remarkable data, and this is all publicly available online. You can go take a look at this. What is useful to think about is this is how we're effectively measuring the share within an area that is inundated by X feet of sea level rise. And so this is this is an example in the on the Upper East Coast of what we're looking at in terms of school districts and what share of them are going to be inundated, are going to be completely covered by 6 feet of sea level rise, as an example. All right. I'm going to skip this in the purpose of time. I kind of mentioned this, but the things that we want to look at is trying to understand, well, how do the changes in the overall sentiment from, so the problem is like we don't have a policy change that's very natural in a different diff setting to look at, right? There's been this broad change in consensus. What we did is we constructed from 22 scientific studies that have been repeated over time what the distribution of projected SLR is at 2100 from all these places and what the kind of distribution looks like. And as you can see, it's been going up and the distribution has widened, which is sort of interesting feature of this data. What we want to do is basically, we want to use this and kind of incorporate these changes when we understand what our non-parametric estimates look like. So we're going to look at a number of channels that are potentially going to affect this. We're going to look at sort of what the time trend looks like. And then we're going to ask, you know, is it a near term or a long run risk that we're thinking about? So is it, you know, the frog that is basically in boiling water and then slowly, eventually you're in trouble in the sense that all things are underwater? Is it long maturity bonds? Or is it basically this worry about severe storm flooding? And then it would basically be long and short maturity bonds that would be affected. This gets a little to this question about what kind of physical damage are you worried about? And then trying to think a little bit about what the investors' beliefs are. So this is what we're going to be looking at in terms of our empirical estimates. I want to make sure I don't go over time, so I may jump a little bit on this. Conceptually, just to make this clear, is we're thinking about this as a very simple non-parametric regression where we're going to be asking, there's a time variant effect, which is the fraction exposed to 6 feet of sea level rise. That's a time invariant effect for a given school district. And then we're going to be putting county fixed effects in and having sort of time effects in. So what we're really asking is the question is, how does the effect of sea level rise change within a baseline area? So that, just to give you a sense, this is a version of what that graph looks like. So this is in every year, this is at the year quarter level. This is saying, you know, relative to 2007, Q1, or Q4 rather, what is the effect of a 6 foot rise, a 1 standard deviation increase in the share of homes that are inundated in 2100 by 6 feet of sea level rise? So, and like I said, you know, a 1 standard deviation increase implies around a 5 bips increase in yields. And it's pretty significant starting, you know, at the beginning or the end of 2013. In contrast, on the West Coast, we really didn't find any impact. This is sort of a problem for us over the course of this whole paper because we've been trying to kind of make sure we understood exactly why it would show up in one place and not in the other. Really what this is consistent is like real concerns about near-term risk of storm flooding. And it's also suggests to us that the tax structure matters a lot. So Prop 13 in California is a big deal. For those who don't know, is like basically Prop 13 makes it like California really can't trust its tax base because what happens is starting in the late 1970s, the appraisal value on house prices could only go up by 2% every year. It could go up with inflation. And so as a consequence, just kind of the underlying real estate base matters less for the underlying for these types of bonds that are being issued. And so it's a different type of risk. And so this kind of micro variation we're going to be exploiting seems to matter less for that. We haven't quite been able to wrap our heads around exactly how to do this, but the main channel that we're focusing on is really thinking about differences in storm surge risk as well as this long-term risk as well. So what do we do when we want to understand this? Well, we say, as I mentioned before, we're going to ask this question of, well, what is the effect of storm surge risk versus the sea level rise risk? And so if we look at long maturity bonds, so this is greater than 10 years. And so it's challenging because it's not like there's any 100-year bonds that are in here. But if we look at bonds that are greater than 10 years in this sample, what we find is that really the SLR risk is the one that is really mattering for yield, pricing the yield of these bonds. So, you know, when we pull this together for all years after 2014, we find a big effect even after we're controlling for the extent to which they're exposed to storm surges. So storm surges here are obviously highly correlated with sea level rise exposure, but not exactly. It's going to be partially a function of, for example, are you within a bay? So like a place like Chesapeake Bay is protected from these types of storm surges in part because of the breaking against the bay, whereas more exposed coastal areas are going to have both at the same time. What we find is that, you know, in the short run, once you control for storm surge, neither of them are significant. There's kind of a positive effect for both. When we do this jointly, what we find is that as you increase the maturity of the bond, that the effect of sea level rise is bigger. And for the shorter term maturity, there's kind of the opposite effect. This is kind of within district year month fixed effect. So we're doing a pretty stringent set of controls in this. Really, the idea here is to ask the question of, you know, we wanted to understand a little bit more of what is the type of risk. Is it purely, I think the way that Johannes put it at the beginning was, is it purely an effect of all of a sudden things are going to have to change? You know, if sea level rise happens and we have 4 feet of sea level rise in Miami Beach, basically, we're going to have to relocate and do a bunch of people versus are people going to be able to stay there? And that's just going to increase the long-term costs of maintaining people there. That's kind of the storm surge risk. Lastly, what we find is that in states where people are more worried about global warming, this is coming from county surveys from Howard et al., that those states, we find a much bigger effect of sea level rise exposure relative to the states where they're not worried. So not worried states are states like Texas, South Carolina, Mississippi, Louisiana. As you can imagine, there's a degree of correlation between the political beliefs and the worried as well. So in the last couple of minutes, I'm just going to show you a little bit of how we're thinking about this calibration, because I think I gave you the
Paul. Yeah. I think you can run a few minutes over, so we have a break after the next talk. So okay. I think it'd be quite interesting to see this model.
Okay, yeah. So this is, I mean, I'm not going to delve too deeply into it, but for those who haven't seen it, this is maybe useful. I'm going to do my best here, and then the details are in the paper in a clearer way. I think anyone who has basically, gotten a finance PhD will have at least seen a version of this. Basically, so the problem is the following: so what I've told you is I shocked basically my credit risk. I'm shocking the credit risk of one area versus another. So one school district versus another within the county. And what we want to understand is like, well, what does that imply that we get a change in yield? So that's a reduced form estimate that really doesn't map to any economic model. So if you wrote down any sort of model, unfortunately, the direction of that could be useful. The fact that I told you is positive is meaningful, but it doesn't really help you calibrate the underlying costs from X amount of sea level rise. So what instead we say is okay, well, let's think about the underlying present value of cash flows that basically are repaying a bond. So what's kind of the Brownian motion? Think about a model that is just underlying Brownian motion reflecting the value of that muni bond. So what we're doing is we're taking a Merton model and we're applying it to muni bonds. Now that doesn't really hold. So I'm going to say this in the most blasé way possible, which is that you're not going to fit yields well in this. The level of the value of this bond, this has been done in the corporate setting as well. It does a very poor job of matching kind of the actual the actual yields that we see in this when we try and calibrate to the riskiness of these underlying bonds. But what it does do an extremely good job of is when you shock the credit, when you think about it, the derivative of this with respect to the credit riskiness, what the change in the yield is. So what do I mean by this? I mean exactly this. Basically, muni bond prices are a function of two pieces. So there's the credit risk factors, which is literally your ability to pay things back. And then there are other non-credit factors as well. There's just, there are other features that are going to affect the value of holding a muni bond. And what the Merton model does a good job of is thinking about the sensitivity of the value of the muni bond with respect to the credit factors and how that maps to changes in the underlying value of the bond, the underlying fundamental value, the present discounted value of the bond, of the cash flows, excuse me. So basically the fact that we don't match the level of credit spreads is really the feature that, well, there are other aspects of muni bonds that are really important for yields that don't have anything to do with the credit factors that are just non-credit related. And so what we're going to do is we're going to be thinking about changes, and that basically the idea is to say we're going to be changing the value of V that's going to be orthogonal to the non-credit component. So we're really trying to use hedge ratios that are not related so that we can look at the piece of the changing underlying fundamental value of the municipality that doesn't have to do with the non-credit component. So the reason I'm being a little bit that we have to make some strong assumptions to get this model to work correctly. But what we are able to do once we're confident in this piece is that we can actually map this basically we can use the change in the yields with respect to the change in sea level rise to then say, well, what does the change in the sea level rise actually imply about the change in the underlying present discounted cash flow values? So what do I mean by that? So, if we think about this model here, what we need is there's going to be a bunch of pieces we're going to have to calibrate. So we have to be able to think about, for example, the volatility of cash flows. And the way that we're going to do this is we're going to calibrate the parameters such that we're going to match observed yields. So we're going to basically calibrate the underlying interest rates. We're going to think about the duration of this bond as being at 7.5. And what we're going to do is we're going to fix the leverage ratio and then solve for the volatility that matches the yields that we see in the data. And what that's going to let us do is it's going to let us say, all right, given a change in yield, so the way to view this graph is if you move from what we were able to do is we were able to basically shock things and get changes in the y-axis. So I'm using my fingers, but there's no reason you should do that. I'm shocking the underlying sea level rise parameter and getting changes in the yields. Well, if what we can start to do is to say, all right, fix basically, fix basically this leverage ratio. So different leverage ratios here are giving us different curves. What's the mapping, given that we've calibrated to the observed yields, how does the change in the yields map to a decrease in cash flows? So what we found, remember, we found a relatively small impact. And what we see here is that they map relatively, there's not a huge amount of variation depending on how levered you are. So we can either map it to a decrease in cash flows. So this is like how much would yields change as a function of decrease in cash flows, or it could be something about the underlying volatility of cash flows. So this is they both map. I mean, the problem is we're over parameterized in the sense that the number of things that could change. But this change in yield implies one of two things, either a change in the volatility of cash flows or just a lump sum loss in the present value of those cash flows. And the implication is that what we talk about in the papers, given our estimates, is that that yield that we found, which is about that a 1 standard deviation increases is about a 5 or 6 bips change in the yield. That means a reduction of about 3 to 6% in the present discounted cash flow of the value of that municipality, or a 2 to 3% increase in the underlying standard deviation. So these are non-trivial increases that sort of are not unreasonable in the sense, right? It's like, these are extremely unrisky bonds. So defaults almost never happen in municipalities. And the fact that we detect this increase in the risk suggests that, wow, it must be a really big shift in the underlying distribution to get this.